Okay, so we're going to talk about Pacific Ocean circulation so that we can talk about El Nino and La Nina. So in order to know what it can be, you kind of need to know what it should be. So typically it's dominated by the two subtropical gyres, the one in the North Pacific and the South Pacific. The western ones, particularly the Kuroshio. Kuroshio is a very large current, warms the west coast of the North Pacific, including Southeast Asia. On the South American side, the Peru or the Humboldt Current brings that nutrient-rich cold water to the East Pacific. This is really important for that area because they such a large fishing industry. Some of the richest fishing in the world, especially for anchoveta and their relatives. And according to the book, the 1/4 of all fish worldwide are caught in Peru. That astounded me. I couldn't figure out whether they meant by mass or individual number of fish, but it's still quite impressive. Now, and we need to talk about Walker circulation. Walker was a naturalist who visited the area, kind of like everybody did, Darwin and his compatriots. And Walker circulation is also known as normal circulation, and some kids think that it either has to be an El Nino year or a La Nina year. That's not true. Typically, we just have Walker circulation. Now, what happens is over South America, we have an area of high pressure. High pressure pushes down, high atmospheric pressure pushes down, which causes air to sink. Sinking air or high pressure air is typically very clear, sunny, fair weather. We get that frequently around here. Meanwhile, in Southeast Asia, around the same time of year, they have low pressure. Now remember, it's warm there, so that low pressure means that the air is full of water. That warm water reaches the atmosphere where it's cooler and it begins to condense, and they get what we call monsoons. So when we have high pressure on one side of the ocean, low pressure on the other, it sort of creates a vacuum through which the air rushes. We call rushing air wind, and these two things generate trade winds. The trade winds then push the equatorial currents, and that's how that circulation begins. Now, I'll show you the picture real quick. This is a picture of normal circulation or Walker circulation in the Pacific Ocean. Over here we have high atmospheric pressure pushing down. Over here we have low atmospheric pressure, which means that warm, moist air rises. Because of this differential, this wind from this area rushes this way. And that's where it picks up all the moisture. And we get the trade winds. The trade winds, in turn, cause the currents to flow. The currents flow kind of this way. There's some issues there with the equatorial equator. And this causes a pileup in this area of warm water. And it's sort of like geostrophic circulation, except there's no Coriolis to disperse it. So sea level is actually higher on that side of the Pacific. That warm water, because it's piled up, also pushes down. And we end up with, it pushes down. And the thermocline on this side is much deeper than it is on this side. So that warm water is heavy and pushes down. So there's just no upwelling. Over here, there's very little warm water, so the cold water upwells and brings nutrients to that area. So you get that Pacific warm water pool. Some numbers to know. The thermocline on the western side is typically about 100 meters deep, and on the eastern side it's only 30 meters deep, which is why the fishing is so good there. Sometimes we get what's called a warm phase. They call this El Nino, and it's not a new idea. It's historically been expected every few years, and they used to call it Años de Abundancia, I think, because what would happen is there'd be increased rain. So the farmers loved it because they got better crops and everything that year. Fishermen did not like it. They would get less catches, and as more and more of the industry in Peru became dependent upon fishing, it became economically devastating. So you need to get warm surface currents and rain. And the reason why that happened is there was a seesaw effect. The low pressure that was typically over Southeast Asia shifts across the Pacific. Walker was the first person to observe this, and he called this southern oscillation. It's really more of an east-west oscillation, but it happened in the southern part of the North Pacific gyres. That's why he called it southern. And that low pressure over South America means that there's no pressure for the trade winds, and they usually either reduce to be non-existent or they'll actually completely reverse. And this, in effect, causes the warm water pool. There's nothing holding it over there anymore, so it flows back. And you can see that in this diagram. This is also in your book, 721A. So now that we used to have low pressure over here and high pressure here. But this shifts. and the high pressure moves way off there. And we have relatively, we have true low pressure over here and sort of high pressure over here. But this low pressure means that this air rises, this air sort of sinks, and we get trade winds that actually flow in the opposite direction. Usually. Sometimes you just get no trade winds. That causes that warm pool of water to flood across the equatorial Pacific. And our thermocline, which used to be here and here, is now all the way across. Upwelling stops. And it has devastating effects on the fishery. There's no more cold nutrient water to drive anything. The immediate effects of the warm phase of El Nino, which some people just call El Nino. I know it's confusing. And so is the whole process. El Nino is typically reserved for just the warm phase. And it's called El Nino because it typically occurs during Christmas time. Is that the water can be as much as 10 degrees Celsius warmer. That's a lot. Sea level increases 20 centimeters during the event. They see increased hurricanes and rain along South America. Meanwhile, in Southeast Asia, when it's monsoon season, that actually decreases. And in Australia, they can have terrible, terrible droughts. Besides just the anchovies being affected, which is what everybody focuses on, there's a section in the book that talks about the marine iguana. The marine iguana is one of the few reptiles that lives in the ocean. It spends large portions of its time there. And unlike most marine reptiles, I guess I'm thinking of saltwater crocodiles here, marine iguanas feed primarily on algae. They scrape the algae off of the rocks. And they do this because algae is so abundant in that area because the cold water brings up nutrients which favors algae over anything else. When that cold water shut off, what they ate shut off, and 90% of their population in the 90s starves to death. It was really kind of bad. Even now, they've only recovered, they have 20% of their original population. And not only, I found this interesting, not only did their population decrease, but also the size of the iguanas themselves decreased. They're much smaller now than they used to be. If we have a warm phase, we also have a cool phase, and we would call this La Nina. Please write La Nina on this. I really should have written La Nina somewhere. Here, I'll write it now. La Nina. La Nina is the colloquial term for cool phase. And it's stronger than normal water circulation. So it's everything you expect with normal circulation, but just more of it. The trade winds are exceptionally strong. You get much more upwelling. The water is much colder. And it typically comes right after an El Nino. And basically the low pressure system swings wildly back to Southeast Asia, and the high pressure comes back into play. Now, table 7.3 is a really good comparison of these, which, winkety wink, you should really, really look at. Clearly, you will be asked to compare all three of these. Now, here's the diagram for La Nina, and it looks very much like Walker circulation. Again, high pressure here. Whoops. Let me go back. We have high pressure here, low pressure here. But last time, the thermocline sort of looked like that. Now it's actually shifted over, so it looks like this. So that's one of the differences. The warm pool was still centered here, but it spread a little farther over, and the cool water was only here. So everything sort of shifted more heavily in favor of the cold side of the Pacific. So make sure that this is La Nina. If I didn't tell you it was La Nina, you should be able to tell the difference compared to Walker. Notice the difference in the thermocline. Oop. Notice the difference in the thermocline. It was over here before. Notice that the warm pool. If I give you two of these pictures, you should be able to tell the difference between this one and this one. And that may mean that you need to take a couple minutes and look at them and see the difference for yourself. So that's it for El Nino and La Nina. For this video, we're going to go into greater detail about all three conditions in the next one.